2. The Economist's Toolkit. Topic outcome. Economists study choices that scarcity requires us to make. This fact is not what distinguishes economics from other social sciences. All social scientists are interested in choices. An anthropologist might study the choices of ancient peoples, a political scientist might study the choices of legislatures, a psychologist might study how people choose a mate, a sociologist might study the factors that have led to a rise in single-parent households. Economists study such questions as well. What is it about the study of choices by economists that makes economics different from these other social sciences? 3 features distinguish the economic approach to choice from the approaches taken in other social sciences. Economists give special emphasis to the role of opportunity costs in their analysis of choices. Economists assume that individuals make choices that seek to maximize the value of some objective, and that they define their objectives in terms of their own self-interest. Individuals maximize by deciding whether to do a little more or a little less of something. Economists argue that individuals pay attention to the consequences of small changes in the levels of the activities they pursue. The emphasis economists place on opportunity cost, the idea that people make choices that maximize the value of objectives that serve their self-interest, and a focus on the effects of small changes are ideas of great power. Economics differs from other social sciences because of its emphasis on opportunity cost, the assumption of maximization in terms of one's own self-interest, and the analysis of choices at the margin. But certainly much of the basic methodology of economics and many of its difficulties are common to every social science, indeed, to every science. This section explores the application of the scientific method to economics. Topic outcome. After you have worked through this learning unit, you should be able to explain how economists test hypotheses, develop economic theories, and use models in their analyses. Explain how the all other things unchanged, ceteris paribus, problem and the fallacy of false cause affect the testing of economic hypotheses and how economists try to overcome these problems. Distinguish between normative and positive statements. Distinguish between microeconomics and macroeconomics. 2.1 Scientific Method. Researchers often examine relationships between variables. A variable is something whose value can change. By contrast, a constant is something whose value does not change. The speed at which a car is traveling is an example of a variable. The number of minutes in an hour is an example of a constant. Research is generally conducted within a framework called the scientific method, a systematic set of procedures through which knowledge is created. In the scientific method, hypotheses are suggested and then tested. A hypothesis is an assertion of a relationship between two or more variables that could be proven to be false. A statement is not a hypothesis if no conceivable test could show it to be false. The statement "plants like sunshine" is not a hypothesis. There is no way to test whether plants like sunshine or not, so it is impossible to prove the statement false. The statement "increased solar radiation increases the rate of plant growth" is a hypothesis. Experiments could be done to show the relationship between solar radiation and plant growth. If solar radiation were shown to be unrelated to plant growth or to retard plant growth, then the hypothesis would be demonstrated to be false. If a test reveals that a particular hypothesis is false, then the hypothesis is rejected or modified. In the case of the hypothesis about solar radiation and plant growth, we would probably find that more sunlight increases plant growth over some range, but that too much can actually retard plant growth. Such results would lead us to modify our hypothesis about the relationship between solar radiation and plant growth. If the tests of a hypothesis yield results consistent with it, then further tests are conducted. A hypothesis that has not been rejected after widespread testing and that wins general acceptance is commonly called a theory. A theory that has been subjected to even more testing and that has won virtually universal acceptance becomes a law. Even a hypothesis that has achieved the status of a law cannot be proven true. There is always a possibility that someone may find a case that invalidates the hypothesis. That possibility means that nothing in economics, or in any other social science, or in any science, can ever be proven true. We can have great confidence in a particular proposition, but it is always a mistake to assert that it is proven. (2.2) Models in economics. Two models in economics. All scientific thought involves simplifications of reality. The real world is far too complex for the human mind, or the most powerful computer, to consider. Scientists use models instead. A model is a set of simplifying assumptions about some aspect of the real world. Models are always based on assumed conditions that are simpler than those of the real world. A model of the real world cannot be the real world. We will encounter our first economic model in the Unit 4 dealing with the production possibilities curve. For that model, we will assume that an economy can produce only two goods. Then we will explore the model of demand and supply in Unit 6. One of the assumptions we will make there is that all the goods produced by firms in a particular market are identical. Of course, real economies and real markets are not that simple. Reality is never as simple as a model. One point of a model is to simplify the world to improve our understanding of it. Economists often use graphs to represent economic models. This unit provides a quick, refresher course, if you think you need one, on understanding, building, and using graphs. Models in economics also help us to generate hypotheses about the real world. In the next section, we will examine some of the problems we encounter in testing those hypotheses. 2.3 Testing hypotheses in economics. Here is a hypothesis suggested by the model of demand and supply. An increase in the price of petrol will reduce the quantity of petrol consumers demand. How might we test such a hypothesis? Economists try to test hypotheses such as this one by observing actual behavior and using empirical, that is, real-world, data. The average retail price of petrol in the United States rose from an average of $2.12 per gallon on May 22, 2005, to $2.88 per gallon on May 22, 2006. The number of gallons of gasoline consumed by U.S. motorists rose 0.3% during that period. The small increase in the quantity of petrol consumed by motorists as its price rose is inconsistent with the hypothesis that an increased price will lead to a reduction in the quantity demanded. Does that mean that we should dismiss the original hypothesis? On the contrary, we must be cautious in assessing this evidence. Several problems exist in interpreting any set of economic data. One problem is that several things may be changing at once, another is that the initial event may be unrelated to the event that follows. The next two sections examine these problems in detail. 2.4 The all other things unchanged problem. The hypothesis that an increase in the price of petrol produces a reduction in the quantity demanded by consumers carries with it the assumption that there are no other changes that might also affect consumer demand. A better statement of the hypothesis would be, an increase in the price of petrol will reduce the quantity consumers demand, ceteris paribus. Ceteris paribus is a Latin phrase that means all other things unchanged. But things changed between May 2005 and May 2006. Economic activity and incomes rose both in the United States and in many other countries, particularly China, and people with higher incomes are likely to buy more gasoline. Employment rose as well, and people with jobs use more petrol as they drive to work. Population in the United States grew during the period. In short, many things happened during the period, all of which tended to increase the quantity of petrol people purchased. Our observation of the petrol market between May 2005 and May 2006 did not offer a conclusive test of the hypothesis that an increase in the price of petrol would lead to a reduction in the quantity demanded by consumers. Other things changed and affected petrol consumption. Such problems are likely to affect any analysis of economic events. We cannot ask the world to stand still while we conduct experiments in economic phenomena. Economists employ a variety of statistical methods to allow them to isolate the impact of single events such as price changes, but they can never be certain that they have accurately isolated the impact of a single event in a world in which virtually everything is changing all the time. In laboratory sciences such as chemistry and biology, it is relatively easy to conduct experiments in which only selected things change and all other factors are held constant. The economist's laboratory is the real world, thus, economists do not generally have the luxury of conducting controlled experiments. .5 The fallacy of false cause. Hypotheses in economics typically specify a relationship in which a change in one variable causes another to change. We call the variable that responds to the change the dependent variable. The variable that induces a change is called the independent variable. Sometimes the fact that two variables move together can suggest the false conclusion that one of the variables has acted as an independent variable that has caused the change we observe in the dependent variable. Consider the following hypothesis: people wearing shorts cause warm weather. Certainly, we observe that more people wear shorts when the weather is warm. Presumably, though, it is the warm weather that causes people to wear shorts rather than the wearing of shorts that causes warm weather. It would be incorrect to infer from this that people cause warm weather by wearing shorts. Reaching the incorrect conclusion that one event causes another because the two events tend to occur together is called the fallacy of false cause. Because of the danger of the fallacy of false cause, economists use special statistical tests that are designed to determine whether changes in one thing actually do cause changes observed in another. Given the inability to perform controlled experiments, however, these tests do not always offer convincing evidence that persuades all economists that one thing does, in fact, cause changes in another. In the case of petrol prices and consumption between May 2005 and May 2006, there is good theoretical reason to believe the price increase should lead to a reduction in the quantity consumers demand. And economists have tested the hypothesis about price and the quantity demanded quite extensively. They have developed elaborate statistical tests aimed at ruling out problems of the fallacy of false cause. While we cannot prove that an increase in price will, ceteris paribus, lead to a reduction in the quantity consumers demand, we can have considerable confidence in the proposition. (2.6) Normative and positive statements. Two kinds of assertions in economics can be subjected to testing. We have already examined one, the hypothesis. Another testable assertion is a statement of fact, such as "it is raining outside" or "Microsoft is the largest producer of operating systems for personal computers in the world." Like hypotheses, such assertions can be demonstrated to be false. Unlike hypotheses, they can also be shown to be correct. A statement of fact or a hypothesis is a positive statement. Although people often disagree about positive statements, such disagreements can ultimately be resolved through investigation. There is another category of assertions, however, for which investigation can never resolve differences. A normative statement is one that makes a value judgment. Such a judgment is the opinion of the speaker. No one can prove that the statement is or is not correct. Here are some examples of normative statements in economics: we ought to do more to help the poor. People in South Africa should save more. Corporate profits are too high. The statements are based on the values of the person who makes them. They cannot be proven false. Because people have different values, normative statements often provoke disagreement. An economist whose values lead him or her to conclude that we should provide more help for the poor will disagree with one whose values lead to a conclusion that we should not. Because no test exists for these values, these two economists will continue to disagree, unless one persuades the other to adopt a different set of values. Many of the disagreements among economists are based on such differences in values and therefore are unlikely to be resolved. 2.7 Microeconomics and macroeconomics. The field of economics is typically divided into two broad realms, microeconomics and macroeconomics. It is important to see the distinctions between these broad areas of study. Microeconomics is the branch of economics that focuses on the choices made by individual decision-making units in the economy, typically consumers and firms, and the impacts those choices have on individual markets. Macroeconomics is the branch of economics that focuses on the impact of choices on the total, or aggregate, level of economic activity. Why do tickets to the best concerts cost so much? How does the threat of global warming affect real estate prices in coastal areas? Why do women end up doing most of the housework? Why do senior citizens get discounts on public transit systems? These questions are generally regarded as microeconomic because they focus on individual units or markets in the economy. Is the total level of economic activity rising or falling? Is the rate of inflation increasing or decreasing? What is happening to the unemployment rate? These are questions that deal with aggregates, or totals, in the economy. They are problems of macroeconomics. The question about the level of economic activity, for example, refers to the total value of all goods and services produced in the economy. Inflation is a measure of the rate of change in the average price level for the entire economy. It is a macroeconomic problem. The total levels of employment and unemployment in the economy represent the aggregate of all labor markets. Unemployment is also a topic of macroeconomics. Both microeconomics and macroeconomics give attention to individual markets. But in microeconomics, that attention is an end in itself. In macroeconomics, it is aimed at explaining the movement of major economic aggregates, the level of total output, the level of employment, and the price level. We have now examined the characteristics that define the economic way of thinking and the two branches of this way of thinking, microeconomics and macroeconomics. In the next section, we will have a look at what one can do with training in economics. Activity 1. Indicate whether the following statements is true or false. T F 1.1 Economics studies human behavior and is therefore classified as a natural science. 1.2 A hypothesis is an assertion of a relationship between two or more variables that could be proven to be true. 1.3 A hypothesis that has not been rejected after widespread testing and that wins general acceptance is commonly called a theory. 1 point for the ceteris paribus assumption means all other things equal. (1.5) If two events occur together, one can conclude that these two events are related. (1.6) We call the variable that responds to change the independent variable. The variable that induces a change is called the dependent variable. (1.7) Macroeconomics deals with phenomena such as total production, total employment, and inflation. 1.8 Microeconomics focuses on specific parts of the economy while macroeconomics is concerned with the economy as a whole. 1.9 The study of the total output of the motor car industry is an example of macroeconomics. 1.10 An increase in the price of tomatoes is a macroeconomic issue. T F 1.11 The total production of beer in South Africa is a macroeconomic issue. (1.12) If somebody says that the current Minister of Finance is doing a good job, he or she is making a positive statement. 1.13 Unemployment is the only important economic problem in South Africa is an example of a normative statement. (1.14) In 1995 the official unemployment rate in South Africa was 29.3% is an example of a positive statement. 2.8 Using graphs in economics. Introduction. A glance through the pages of this guide should convince you that there are a lot of graphs in economics. The language of graphs is one means of presenting economic ideas. If you are already familiar with graphs, you will have no difficulty with this aspect of your study. If you have never used graphs or have not used them in some time, this section will help you feel comfortable with the graphs you will encounter in this text. In economics, we usually show the relationship between two or more variables on a graph. A variable is any unit or factor that can change, for example the price or the demand for a product or the supply of a service or any other economic element. A considerable portion of your studies in economics will be concerned with establishing how a change in one economic variable will influence another variable, or other variables. Due to the large number of variables in any economy, it is, however, necessary to isolate two variables at a time and pretend that other variables will not change, will stay constant, while we look at the two variables we are interested in. For example, if we want to examine the relationship between the price of red pens and the supply of red pens, we need to ignore the possible effect of taxes, inflation, etc. on the decision to produce the pens. We therefore look at supply of a product and its price in isolation and pretend that the rest of the variables remain constant. We refer to this as the ceteris paribus principle. Typical examples of the relationships we study in economics are: how does a change in the price of a product influence the quantity demanded of that product? If the supply of product A increases, how will this influence the price of A? What effect will a decrease in income have on the spending of an individual? How will a decrease in government spending influence total employment in a country? In the rest of the learning unit, we will examine how the relationship between two variables may be presented in the form of a graph. The axes of a graph. Because we normally have two variables which we want to relate to each other, our graphs must be drawn in a two-dimensional space. For this we need two lines, also called axes, on which to measure the values of each variable. In the following figure, both axes start from the same point of origin, 0, and are drawn horizontally and vertically respectively. On the horizontal axis the values of x are measured, and on the vertical axis the values of y are measured. The shaded area provides us with the space in which to indicate the relationship between these two variables. To show how we use the two-dimensional space created by these two axes, a time series graph will now be drawn. A time series graph is very common in economics. It measures time, e.g. days, weeks, or years, on the horizontal axis and any other variable, or variables, which we want to relate to time on the vertical axis. The following table denotes the production figures for South Africa. The figures show an increasing trend. By plotting the information contained in the table on a two-dimensional graph, we are able to gain a much better idea of the production pattern. In the following figure, production, gross domestic product, is measured on the vertical axis and the different years are marked out on the horizontal axis. Each year's value is plotted on the graph by measuring the value of production on the vertical axis in line with the corresponding years on the horizontal axis. For example, production for 2005, R2359 billion, is obtained by measuring a vertical distance of R2359 billion from the horizontal axis. This is done for each year's production. For example, a value of R27086 billion corresponds with the year 2008, R2899 billion with 2012 and R3008.6 billion with 2014, and so by plotting the information contained in the table below on a two-dimensional graph we are able to gain an idea of the national savings pattern for South Africa between 2005 and 2015. In the following figure, national savings as a percentage of GDP is measured on the vertical axis and the different years are marked out on the horizontal axis. After each year's values are plotted, a graph or line is obtained by connecting all the dots. The continuous line represents national savings for the 11-year period. From the figure we can immediately see that national savings in South Africa increased from 2008 to 2010 before decreasing from 2011 to 2015. This graph is called a time series graph because time is measured on one of the axes. Other types of graphs. Time series graphs are not the only type of graph we use in economics. Using graphs allows us to present the relationship between two economic variables in a meaningful manner. From this type of graph, it is relatively easy to establish whether a general pattern, or trend, exists between two variables. Typical patterns that are found in economics are the following. Variables that move up or down together. Variables that move in opposite directions, that is, when one goes up the other goes down. Variables that are not related to each other in any way. We will now explain these relationships in greater detail by using practical examples. Variables with a positive relationship. If two variables move together in the same direction, we say that there is a positive or a direct relationship between them. An example of a positive relationship is that between speed and distance traveled. The higher your speed, the greater the distance you can travel in 5 hours. This is illustrated in the following figure, where a straight line is drawn to show the relationship between speed and distance traveled in 8 hours. Example of a linear positive, direct, relationship. Because the relationship is a straight line, we call this a linear relationship. Furthermore, because the line rises from left to right, the slope or gradient of the line is positive. In economics, any line in a graph is called a curve, irrespective of whether it is a straight line or not. Let's calculate the value of the slope of the line in the above figure using the following formula. The diagram shows that when the speed increases from 60 to 120, shown on the vertical axis, the distance traveled in 5 hours increases from 300 to 600, shown on the horizontal axis. The slope of this line is equal to 0.2. The positive value indicates that the value on the horizontal axis changes in the same direction as the value on the vertical axis, i.e. when the speed at which traveling takes place increases, the distance covered in 5 hours also increases. You can calculate the slope of this line when the speed increases from 20 to 60. Is your answer 0.2? That is because this is a straight line, and the value of the slope will be the same everywhere on this line. Another example of a positive relationship is that between the number of bakers per day and the number of loaves of bread that are baked. Note that the line in the figure below is not a straight line, but a curved line. Although the relationship is still positive, it is a non-linear relationship. It is reasonable to assume that bakers per day will not influence production in a linear fashion, but that the curve will begin to flatten somewhat as more loaves of bread are produced per day. This means that when all the best bakers have been hired, the additional bakers that will be hired will produce fewer loaves of bread extra, thus production still increases when additional bakers are hired, but by less. In other words, the slope of the curve becomes less steep as more loaves of bread are produced. Too many bakers can even reduce production. The slope or gradient of the curve in the figure is positive, because the relationship between the two variables is positive. Example of a nonlinear positive, direct, relationship. As this curve is not a straight line, the value of the slope will change. The value will, however, be positive everywhere on the curve because the curve slopes upwards. Variables with a negative relationship. A relationship between two variables that move in opposite directions is called a negative or an inverse relationship. An example of a negative relationship is that between the time one spends traveling to work and back, and the leisure time at one's disposal. The more time spent on the road, the less leisure time at one's disposal. Here we can again assume a linear relationship between traveling time and leisure time. Also note that the slope of the curve is now negative, like going down a hill, because of the negative, inverse, relationship between the two variables. Although we haven't given you an example of a graph showing a nonlinear inverse relationship, there are many examples of this kind of relationship in the real world. Example of a linear negative, inverse, relationship. Variables that are unrelated. There are many things that are totally unrelated to each other. The price of oranges will have no influence on the marks we obtain for a UNISA assignment. Nor will the rainfall in South Africa have any influence on coal production in Wales. Examples of unrelated variables are given in the following figures. Note that the non-relationship in these cases is denoted by either a horizontal or a vertical line. The slopes of these curves are either zero, in the case of a horizontal line, or infinitely large, in the case of a vertical curve. In both cases, the value of one of the variables does not influence the other variable at all. Vertical and horizontal curves. Activity 2. Indicate whether the following statements is true or false. T. F. The origin is the point where a graph starts. A graph showing a positive relationship between stock prices and the nation's production means that an increase in stock prices causes an increase in production. If the graph of the relationship between two variables slopes upward to the right, the relationship between the variables is positive. T. F. Graphing things that are unrelated on one diagram is not possible. The slope of a straight line is calculated by dividing the change in the value of the variable measured on the horizontal axis by the change in the value of the variable measured on the vertical axis. For a straight line, if a large change in y is associated with a small change in x, the line is steep. The slope of a curved line is not constant. Ceteris paribus means everything else changes. Demonstrating how an economic variable changes from one year to the next is best illustrated by a time series graph. If variables x and y move up and down together, they are positively related. 2.2 If the total amount of goods produced in South Africa has generally increased, on a time series graph illustrating the total amount produced, you would expect to find A. An upward trend. B. Linear relationship. 2.3 If the relationship between two variables, x and y, is a vertical line, then x and y are A. Positively correlated. B. Not related. 2.4 A linear relationship always has a constant slope. Always slopes up to the right. 2.5 Use the figure below to answer the following questions. What is the slope of the line between x equals 2 and x equals 3? How does the slope of the line between x equals 4 and x equals 5 compare with the slope between x equals 2 and x equals 3? Use the data in the table below to answer the following questions. X, Y, Draw a graph to show the relationship between x and y. Over what range of values for x is this relationship positive? Over what range is it negative? Calculate the slope between x equals 1 and x equals 2. Calculate the slope between x equals 5 and x equals 6. Answers to the activities. Activity 1. 1.1 False. Economics studies human behavior and is therefore classified as a social science. 1.2 False. A hypothesis is an assertion of a relationship between two or more variables that could be proven to be false. 1.3 True. 1.4 True. 1.5 False. This is called the fallacy or false cause. 1.6 False. We call the variable that responds to change the dependent variable. The variable that induces a change is called the independent variable. 1.7 True. 1.8 True. 1.9 False. The motor car industry is one specific industry and thus a microeconomic issue. 1.10 False. Tomato is a specific product and therefore a microeconomic issue. 1.11 False. The production of beer is a specific market for a product and therefore a microeconomic issue. 1.12 False. It is a value judgment and therefore a normative statement. 1.13 True. It is a value judgment and therefore a normative statement. 1.14 True. It is based on fact. Activity 2. 2.1 A. False. The origin is where the horizontal and vertical axes start, not where the graph starts. B. False. A relationship does not necessarily mean that one of the variables causes the other. More intricate econometric tests are necessary to determine causality. True. If the graph of the relationship between two variables slopes upward to the right, the relationship between the variables is positive. False. It is, for example, possible to show the number of houses built in Gauteng every year from 2000 to 2015 and the number of ducklings born in Dublin in Scotland every year from 2000 to 2015. It is not clear why anyone would want to do such a thing, but it is certainly possible. False. The slope of a straight line is calculated by dividing the change in the value of the variable measured on the vertical axis by the change in the value of the variable measured on the horizontal axis. True. For a straight line, if a large change in y is associated with a small change in x, the line is steep. True. The slope of a curved line is not constant. False. Ceteris paribus means everything else stays the same. True. Demonstrating how an economic variable changes from one year to the next is best illustrated by a time series graph. True. If variables x and y move up and down together, they are positively related. If the total amount of goods produced in South Africa has generally increased, on a time series graph, illustrating the total amount produced, you would expect to show an upward trend. If the relationship between two variables, x and y, is a vertical line, x and y are not related. A linear relationship always has a constant slope. 2.5. Up the slope equals the change in the variable measured along the vertical axis divided by the change in the variable measured along the horizontal axis, or 2 minus 1, 1. Equals 1, 3 minus 2, 1. B. How does the slope of the line between x equals 4 and x equals 5 compare with the slope between x equals 2 and x equals 3? The figure shows a straight line. The slope of a straight line is constant, so the slope between x equals 4 and x equals 5 is the same as the slope between x equals 2 and x equals 3. 2.6a. The relationship between x and y changes when x is 4. The relationship is positive between x equals 1 and x equals 4. Between x equals 4 and x equals 6, the relationship is negative. The slope equals delta y slash delta x, or, in this case, between x equals 1 and x equals 2, the slope is 2 minus 4, minus 2. Equals 2, 1 minus 2, minus 1. D. Between x equals 5 and x equals 6, the slope is equal to 7 minus 6, 1. Equals minus 1. 5 minus 6, minus 1. Checklist. Well. Satisfactory. Must redo. Concepts and relationships. I am able to. Describe the three distinguishing features of economics as a social science. Distinguish between theory and reality. Explain the concept ceteris paribus. Distinguish between positive and normative statements and to give examples of each. Distinguish between microeconomics and macroeconomics and to give examples of each.